Students will today discuss about DC generator. As you know that energy neither created nor destroyed, but it can be transferred from one form to another form. So as we are talking about the electrical engineering, so we are converting some other form of energy into electrical energy and which we are using in our day-to-day life. So we are using two types of energy. One is alternating current, another is direct current. And today we are going to discuss about the direct current generator. Generator means which is exactly not generator, which is converting one form of energy to another electrical energy. That is called the generator, and the output of the generator is DC. So we say it is a DC generator. First we will see what is a DC generator, then we will see what are the different construction inside and what are the different parts we are having inside the generator and which is helpful for the conversion of energy, one form of energy to another form. Then we will go for the what are the principle behind. So today we will see only two things. One is DC generator, what is called DC generator, and what are the different parts. So as I said, DC generator is nothing but it converts mechanical energy into electrical energy. Converting the mechanical energy into electrical energy, the machine is, and the output is DC, the machine we say it is a DC generator. So what here I have given, here it is given the overall view of DC generator, and the principle is that the machine converts mechanical energy into electrical energy. The energy alternation process is the principle of principle of energetically induced electromotive. So the principle behind it is EMF, or Faraday's law of electromagnetic induction. So next, this is the major principle, and let us see what are the different parts involved in the DC generator. So there are various parts as it is shown in this diagram. These are mainly it is divided into two parts. One is called stationary part, another is called the rotating part. In the stationary part, as you know, as I said, the electromotive force and the principle behind the conversion is Faraday's law of electromagnetic induction. So we need a magnetic field. To need a magnetic field, we need a pole, a magnetic pole. So first, the outer part of this is the outer part. It is a mechanical support for the DC generator, and we say it is our yoke. It is called the yoke. Yoke is nothing but it gives the mechanical support to the mechanical support to the DC generator. It gives the mechanical support to the DC. Also magnetic field also it carries magnetic field. In the yoke there are different magnetic poles. Here I have shown 4 pole DC generator machine. The poles are north south. These poles are fixed with the yoke. Then the main this thing reason behind the magnetic poles is that it provides magnetic field. As I said, it is divided into two parts. One is stationary part, another is rotating part. In between stationary and rotating part there is a gap, and that in that gap air is present. So we say that it is air is in between stationary part and rotating part. In stationary part we have 4 things. One is called yoke, pole, and this is called pole shoes. And in the rotating part we have having armature winding, and we have a commutator, we have other parts. So one by one we will discuss what are the different parts. As I said, yoke is the outer part of the DC machine or DC generator, which gives the mechanical support for the machine, as well as it also carries the magnetic field. So with the yoke, next is your magnetic poles. That is called, here it is written poles. Poles means magnetic poles, which provides magnetic field within the air gap, and that magnetic field must be uniform. If it is not uniform, then what will happen? If it is the magnetic field is not uniform, then the EMF produced will not be uniform, and the EMF strength will be less, and the production or the conversion process will be hampered. So we want to make the magnetic field is uniform, so the magnetic poles and the magnetic pole, this bottom part of the magnetic pole is called, this called is your pole shoes. This is bow in nature. Bow in nature means it gives the uniform magnetic field within the air gap. If it is flat, then at the center the magnetic field strength will be higher, and later on if it moves to the left to right, then the magnetic field strength will gradually decrease. So for that purpose, the magnetic pole shoes are bow in nature, so that it can produce the magnetic uniform magnetic field. Next is in the stationary part is called field winding, which is very important part of the DC generator. Field winding means it provides it. These are the permanent magnets. What I have shown, these are the permanent magnets. The permanent magnets are giving the magnetic field which is not strong, or to make the magnetic field stronger, we want to make the magnetic poles an electromagnet, so that the field windings are provided over the magnetic pole, so that the magnetic field strength within the air gap will be higher. These are called field winding. Then we'll move to the rotating parts. So in our stationary part we have yoke, magnetic pole, magnetic field winding. All these are in the stationary part. In the rotating part, the main rotating part or the major part is called your armature. Armature is a rotating part. This portion is called your armature, in which armature conductors are provided. These small dot things are armature conductors. They are placed within the slots of the armature, so that it can carry the current, so that the magnetic field or the alternating current will converted to the direct current. Later on I will explain when I will go to the working principle. So anyway, this is the armature is the rotating part after the air gap, and within the armature conductors are provided, as it is shown. Armature conductors are provided. Then next is your commutator. This portion is called your commutator. Commutator, what it does, it converts AC to DC or DC to AC. So the same machine we can also use as a motor also. When you are using motor, we are giving AC supply, and it gives you the converts to the DC. So here our objective is to produce DC output. So when the magnetic field cuts, it produces alternating current. That alternating current gives the goes to the armature winding, and that armature winding, after that, that alternating current is converted into direct current by the help of commutator. So the work of the working of the commutator is converting AC to DC or DC to AC, vice versa. Then with after the commutator, there are brushes are fixed within the commutator, so that the brushes, the carbon brushes, they have to collect the current converted by the commutator, and through that commutator, through the brushes, the current goes to the output. So in this process, the DC generator converts the mechanical energy as an output. Where you get the mechanical energy? You can see there is a shaft here. The shaft we are rotating, as you have students, you have seen when you are starting the generator, though we are giving the mechanical force with the help of our hands. So we are rotating the shaft, so that the mechanical energy we are giving as input to the machine, and when the shaft is rotating, it is connected with the armature, and the armature starts rotating. When the armature starts rotating, it disturbs or it changes the magnetic field within the air gap provided by the magnetic poles. In this process, the conversion process is given, and other things are, this is bearings and gear and all. These are the other parts, important parts, and the interpoles are provided to give the magnetic field strength open. So today what we have seen, what is the principle of DC generator, and what are the different parts. These are the things. In the next class, we'll go for that principle of DC generator and how does it works and how it converts the mechanical energy to electrical energy. Thank you.